Hello everyone. We are going to learn about amino acids. Amino acids. So what are amino acids? They have two functional groups. One is amino group NH2. This is amino group. The nature of this group is basic. Basic in the sense they accept proton. They are proton acceptor. And the other group is acid, which is basically carboxylic acid. When I say acid, they are acidic in nature. What I mean by that, they are proton donors. Basically, the amino acids are monomers of proteins. They are found in proteins. They are obtained by hydrolysis of proteins. Hydrolysis means when you add water to proteins, simply to say their protein will become simple amino acids in certain conditions, let us say. So now how they are represented. So the general formula of amino acids. General formula of amino acids. I can write like there is a carbon, a hydrogen, or I can say NH2, COOH. So this is one way of representing amino acids. There is another way also. If I rotate this in this direction towards left, so what I will get, the NH2 comes to the left, C is at the center, and the hydrogen go to the up, and COOH will be at the right, then R go to the bottom. So both are amino acids only, generally they are represented. So the NH2 group, I said this is the amino group. Even this is the amino group. And the COOH group is acid, that is carboxylic acid. And the COOH group is also acid. So you may wonder what is this R. This R group can be any organic group. Any organic group or hydrogen. Basically, there are different kinds of amino acids. This structure represent the amino acid which is 2-amino carboxylic acid. 2-amino carboxylic acid. What this 2 refers to, if I consider this carbon, the carboxylic carbon, this is always numbered as 1, the first carbon. Then the next carbon is the second carbon. The second carbon carries, or the second carbon is attached to the amino group. So that is why it is 2-amino acid. So 2-amino carboxylic acid, any amino acid which has the carboxylic acid group, and the next carbon carries or connected to an amino group, NH2 group, that is the 2-amino carboxylic acid. So we have introduced amino acids now. Now we are moving further with the zwitterions. So how to go about zwitterions? So let's move to the zwitterions. So how will I talk about zwitterions? So let me talk about zwitterions. What are zwitterions? So we have already seen amino acids carry acid group and a amino group or else a basic group. So let me say I have a carbon and I have, let me say, NH2, then I have hydrogen here, then R here and COOH here. Okay. So now let me say this is the acid group. It can donate acid. And let me say this is the amino group. So this can accept proton. So when they are in the same molecule, what they are going to do? Carbon, hydrogen, R. Now this one is going to become NH. Already it has 2 hydrogen and it is going to accept 1 hydrogen from the acid, so it becomes NH3 positively charged. And as an acid, the COOH group donates its hydrogen, so when the hydrogen is lost, it becomes negatively charged. So this is known as zwitterion. Zwitterion means it has 2 charges, one is positive, the other one is negative. So there are 2 charges in an ion, that's why it's known as a zwitterion. It's also known as dipolar ion. So we need to know how to draw the structures of zwitterion for different amino acids. So we'll try to draw that. So first let me give you a specific example of amino acids. So I'll take one amino acid. Okay, so I'm just writing one amino acid CHR. Instead of R, what I am going to have is I'm going to have hydrogen, and I have COOH group, then also I have NH2 group, now this is basically known as glycine. So if I want to draw the zwitterion of glycine, I have carbon, so I have a hydrogen here. Instead of the R group, I have one hydrogen here. Then I have the COOH group. The COOH group is going to lose its acidic hydrogen, it becomes COO minus, and the NH2 group is going to gain the hydrogen, it becomes NH3 positive. So this is the zwitterion of glycine. I can also write the another example. The other example is I have carbon again, I have hydrogen, then I have other 3 bonds, no? One is as usual COOH, the other one is as usual NH2. Here I am going to use CH3 group as the R group, CH3. This is basically alanine. This is an amino acid, alanine. So now if I want to draw this zwitterion, so I have carbon, I have hydrogen, then I have other three groups, no, in that, which is not disturbed, the CH3 is not going to get disturbed. And when I consider COOH, it's going to lose or donate its hydrogen, and who is going to gain? The amino group is going to gain the hydrogen NH3+. So this is how I write zwitterion. So these zwitterions behave differently in different medium. Medium in the sense, when you increase the pH or when you decrease the pH, they are going to behave differently. So we are going to talk about that also. So when I consider the zwitterion of glycine or any general, I will take CH, general R, then I have COO minus and NH3 plus. When I consider the medium as acidic, the medium is acidic means the medium has hydrogen plus ions. The pH is less than 7. Now what is going to happen? This is a positive ion supplied by the medium, and out of this positive and negative pole, the negative pole is gain this positive ion. So you are going to see NH3 plus is intact, it's not going to get affected, and the hydrogen stays as it is, the R stays as it is, the COO minus is going to gain this hydrogen. So actually this hydrogen is gained by the acid group. So now you are getting a positive ion because the negative charge was neutralized by the hydrogen plus given by the medium. If suppose I am having a basic medium, everybody knows what is a basic medium. The basic medium provides OH minus ion. Again I am taking a general structure. If suppose the R is replaced by hydrogen, it is glycine. If the R is replaced by CH3 group, it is alanine. So now I am just taking general, then I am having a basic medium. Basic medium means it's going to provide OH minus. The pH will be greater than 7. Greater than 7. So what will happen? The amino group which has excess of hydrogen, it is going to give its hydrogen and it becomes NH2. Then you are going to get water formed. So when I just do like this, if suppose this is having 1, 2, then 3 hydrogens. One of this hydrogen is being, let me say here, water, HOH. So the hydrogen comes from that shaded, yellow shaded. So remaining it becomes NH2. Then if I can shade this OH, let me say, this is OH. So this OH here. So they both form water and the zwitterion become now negatively charged. So this is negatively charged. Negative ion. Basically, there is a point of pH, the pH at which neither positive ion nor negative ion is dominating that pH is called isoelectric point. That pH is called isoelectric point. At acidic pH, positive ion dominates. Basic pH, negative ion dominates. Every amino acid is going to have a particular pH. It's not the same. A particular pH at which neither the positive ion dominates nor the negative ion dominates, and that pH is called isoelectric point. So we have done almost 2/3 of the amino acids part. Now we are moving on with the last part, how two amino acids react to form a dipeptide. That's what we are going to talk about. And we are going to learn about peptide linkage and what I mean by dipeptide and what kind of reaction it is. That's the three things we are going to talk about. So if suppose I am having two amino acids, let me say I am having glycine and alanine. There are two amino acids I am having. So the glycine looks like this, NH2 C H H COOH. I'll write like this, COOH. So always the first amino acid which is reacting has to be written like this. The carboxylic acid group on the right side, amino acid group on the left side. Then the second one is said as alanine. Alanine I am going to write like this as usual. The left side amino group and the right side acid group. The R group in alanine is CH3, C double bond O OH. So now what is going to happen? This reaction is called condensation reaction. The type of reaction is condensation reaction. What I mean by condensation reaction? Two molecules combine together and there will be a loss of small molecule. What is the mass? What is the loss, or which molecule is going to get lost? That's what we are going to talk about. So which molecule is going to get lost? We are going to talk about this is the molecule is getting lost. What is that molecule? If you look at this is the molecule which is going to be removed, lost. So what is going to be lost? Water is removed. H2O is removed. So now when I want to write the product, how to write the product? I am going to remove this box and I am going to connect remaining. So how will I write? I have H2, N, C, H, H. I am just bringing all these things, particularly this part. The NH2 here, C here, hydrogen, hydrogen, then C double bond O, that's there. But this OH group is removed. So I am going to remove that. Then this side the hydrogen is removed. Then I'm having only nitrogen. I'll connect it with the hydrogen. That's it. Then remaining I'm write as it is. I'm going to write as it is. I don't change any order. I'm going to write like this. So this is called a dipeptide. This is called a dipeptide. This is called a dipeptide. Why dipeptide? It is made up of two amino acids. Made up of two amino acids, or else it is the condensation product of two amino acids, and this bond how it is, it's look like this, C double bond O NH. This bond, which is the amide linkage, this bond is known as amide linkage. Here technically it is said peptide linkage. So peptide linkage. So you need to know, identify where is the peptide linkage. The peptide linkage is because of the condensing of carboxylic acid group and amino group. So this is known as dipeptide. It is a condensation of two amino acids, and the bond between the two amino acids by the removal of water is basically dipeptide linkage or else amide linkage. So what are the things we learned today is, one is what is amino acid, what are amino acids, and how to write the structure of zwitterion. What will happen to the zwitterions when the pH is increased or decreased, or what will happen to the zwitterion when acid medium or basic medium is there, and what do you mean by isoelectric point, and how two amino acids can condense to give a dipeptide, what is an amide linkage, what is a peptide linkage, whether they are different or same. They are same. Amide linkage and peptide linkage are same. So I hope this video will help you to revise again and again this topic. Whenever you get a doubt, you can visit a particular point and you can get convinced and clarified yourself, I hope. Thank you for watching.